All right, class. So let's get going here. What we're going to talk about today is the overarching thing is we're going to learn how to simplify monomials. So monomial obviously stands, well, mon, that's one, and a monomial actually means one term. So it's a one-term expression, and we want to just simplify it. Now, this has to do a lot with exponentials, so we're going to go over the three basic properties of exponents right now. You probably already know this, but let's review. So first one is, what if I have x to the fourth times x squared? Well, that is going to equal x to the sixth, and the reason is that x to the fourth has 4 x's, x to the second has 2 x's, and if I were to multiply all of them together, well, we notice, oh look, there are in fact 6 x's. So that's why it's x to the sixth. So the property, we'll just kind of note it as this. If I have x to the a times x to the b, what we can do is simply add the two exponents and get x to the a plus b. So that's multiplication. What about division? Division is a little trickier, but it's not too bad. So let's just do an example first, x cubed. Well, let's just write that out. X to the fifth is 1, 2, 3, 4, 5. 5 x's. X cubed is 1, 2, 3. Now, since everything is multiplied and divided, we can rearrange this any way we want, and nothing really changes. The expression doesn't change. The meaning of the expression doesn't change. And so I can actually choose to just take a single x and divide it by another single x. And so I get x divided by x. And anything, 2 divided by 2, 5 divided by 5, anything divided by itself is 1. So that cancels. So then we notice, oh, well, here's another pair, here's another pair. And so all three of those pairs cancel, and I am in fact left with an x squared on top. When you divide everything away, there does happen to be a 1 on the bottom, but obviously something divided by 1 is just that something. So you don't need to write the 1. But so x to the fifth over x cubed is x squared. So the more basic property can be described as, if I have x to the a over x to the power of b, I get x to the power of a minus b. What if, so let's go over this real fast though. What if I flip them and I say x to the fifth, or so x to the fifth over, let's do x to the 10th, something like that. Well, same idea, right? We can cancel out all these pairs. Now, how many pairs of them are there? Well, there's 5 x's on top and 10 on the bottom. So obviously I can match up 5 pairs. I cannot match up all of them, but I can match up 5 of them, which leaves me 5 on the bottom. So just like here, where all of these disappeared, and so I got a 1, since something divided by itself is always 1, all of these x's disappear, and so I get a 1 on top. This is 1 over x to the fifth. However, if we follow our property of where I can exponent and subtract the bottom one, if I follow that property, I would actually be ending up with x to the 5 minus 10, or x to the negative fifth, which brings us to our next property, basically negative exponents. So what can you do with negative exponents? Well, when you have a negative exponent, you can just move it. Meaning, if I have an x to the negative fifth on top, I can move it to the bottom as x to the fifth. And in fact, the exact same thing is true is if I had a 1 over x to the negative third, it would in fact be just simply x to the positive 3. So if you have a negative exponent on the bottom, you can move it to the top. So here's our property of division. with exponents, in which case what we can do is we can subtract, or in other words, cancel out. But also, if we have a negative exponent on the bottom, we can move it to the top and make it positive. Or if we have a negative exponent on the top, we can move it to the bottom and make it positive. In general, we like positive exponents. It's not very often that you see as a final answer or a simplified form with a negative exponent. So try to avoid them. All right, moving on. Last property. All right, last property. Let's do the, what if I have x cubed that's also squared? Well, let's just write this out. If I'm squaring something, that means I have two of them. So in fact, I have 2x cubed, which, going back to our original property, that's just x cubed times x cubed, which we understand as x to the 6th. And that is why x cubed squared is actually x to the 6th. In other words, x to the a to the power of b is simply x to the a times b. So you can simplify it as just a multiplication. All right, good. So now, with that, let's actually start simplifying some monomials. So let me come up with kind of some easier ones, and then we'll go from there. So let's move this paper up a little bit. All right, so let's do an easier one. Let's do something such as 5x squared. I'm going to multiply that by 4x to the 4th. Well, since this is all one big multiplication, I can rearrange this in any way. So in fact, since I can rearrange this in any way, I can basically assume that this 5 is multiplied by this 4. And I know what 5 times 4 is. It's 20. I also have an x squared and an x to the 4th. I can put those next to each other and multiply them. And we already know that that property means that it's going to be x to the 6th, 4 plus 2. And so 5x squared times 4x to the 4th is 20x to the 6th. So that's kind of a simple one, right? Let's do another simple one, but this time, instead of the two monomial terms being multiplied, let's have them be divided. So what if I do, let's say, 12x to the 6th over 4x to the 2nd? Well, now that they're being divided, well, we treat the coefficient, the number in front of the variable is called a coefficient. So let's treat the coefficient just like regular numbers. And if I had 12 divided by 4, that would easily be a 3, right? And since it's 12 divided by the 4, the 3 is on top. Now I have x to the 6th divided by x to the 2nd. Well, remember our properties. And what you want to do is you want to cancel out all of the x's that come up with a pair, meaning there's an x on the top and there's an x on the bottom. You can cross them out. Well, since there's two x's on the bottom, we can cross out two of these and two of those. When I cross out the two x's on top, that leaves me with x to the 4th. So this would reduce down to 3x to the 4th. Let's make it a little more complicated, though. So here, we've got a couple examples here. Let's make it a little bit more complicated as far as a fraction is concerned. Let's say we have 25x to the 2nd over 5x to the 7th. Well, 25 divided by 5 is a 5. And x to the 2nd divided by x to the 7th, well, we notice the 7 and the 2 is smaller, so that means I can cross out two of these, which means I'm going to get an x to the 5th. But where is that x to the 5th? It's on the bottom. So the 5, since the 25 is on top, the 5 is on the top, and the x to the 5th is actually on the bottom. So hopefully that makes sense. All right, good. Let's do one more good example here. Let's do an exponential, in fact. few more, but let's do an exponential. So let's say I have 3x squared y to the fourth, and I am going to square it. Well, if I square something, that means I take it and I multiply by itself. In other words, this is going to be 3 times another 3. Basically, if you have an exponent and it's outside of a parentheses and everything on the inside is a multiplication, you can distribute that square to everything. So 3 squared is 9. X squared squared is, well, 2 times 2 is 4. So it's x to the fourth. And y to the fourth to the second is y to the eighth. So we got 9x to the fourth, y to the eighth. All right, let's do another one. So hopefully you're kind of noticing we're getting a little more complicated as we go along. So if you want to pause now and start to do the homework, you can probably get through a large amount of it, maybe all the way up until, I would say, well, we haven't gone over any negative, so I would say the whole front page. Probably more examples. Specifically, I want to do an example or two with some negative exponents. Okay. All right, so let's try that. Let's try an example with some negative exponents. I'm going to do a pretty complicated one here. Okay, so I'm going to say we're going to have a 5. Then I'm going to open a parentheses. I'm going to say 2x squared y to the third. And then I'm going to raise this thing to the negative second. I'm then going to go to the bottom here. And I'm also, on the bottom, we're going to divide this by, let's say, 10. And then I'm going to say x to the fourth, y to the negative seventh. Okay, so let's first, so if you have something complicated like this, the very first thing we want to do is we want to kind of deal with what's inside the parentheses. Okay, we got to deal with what's inside the parentheses and this exponent that's on the outside. Now, instead of immediately thinking 2 to the negative 2, what I want you to do is I want you to rewrite this whole thing just with the negative 2 as the exponent, basically. So 5 times. All right, I'm going to get 2 to the negative 2 here. This is going to be x to the second to the negative second, so that's x to the negative fourth. This is y to the third to the negative second. Well, that's going to be y to the negative sixth. Okay, the bottom here goes 10. X to the fourth, y to the negative seventh. Okay, now, the thing that really makes this problem confusing is all of these negative exponents. Well, if we have so many negative exponents, we want all positive. If something has a negative exponent, to make it positive, all you have to do is switch it. Remember the property? So, I am actually going to rewrite this. So the 5 is going to stay up here, because it doesn't even have an exponent, so we can just leave it. This 2, though, has an exponent that's negative, so I'm going to actually move that to the bottom as 2 squared. This x, also negative, so x to the fourth on the bottom. This y, also negative, so y to the negative sixth on the bottom. Now let's move to the bottom. 10, nothing, so let's leave 10 as a number. X to the fourth, already positive, so we also leave that on the bottom. But y to the seventh, that should actually go on top as y to the seventh, right? Since this is y to the negative seventh, let's move it to the top and make it positive. Now we have all positive exponents, except for the fact that I made a mistake and wrote this as negative, right? So, by the way, that's also positive. Just, sorry about that. Okay, now, let's deal with the numbers. I have a 5, I have a 2 squared, which we could immediately cross out and write as a 4, and I have a 10. this 5 is divided by 4. Can I reduce that at all? Answer is no. But the 5 divided by 10, I can. In fact, 5 divided by 10, the 5 would go away. The 10 would just be a 2. Okay? So, as far as the coefficients are concerned, there is no coefficient on the top. In general, that means there's a coefficient of 1, since 5 divided by 5 is 1. All right, so the thing on top is just a 1. We don't need to write it. The coefficient on the bottom is a 4 and a 2. This whole thing is multiplied, and so when we have numbers, 4 times 2 is just 8. So we're going to have an 8 on the bottom. All right, let's look at the variables now. So, done with the coefficients. Let's look at the variables. What about x's? Well, I got an x to the 4th on the bottom, and I have another x to the 4th on the bottom, and they're multiplied. Well, if I have 4 x's here and another 4 x's here, how many x's do I have? I've got 8 of them, and they're all on the bottom. What about the y's? Well, I've got 7 y's on top, and I got 6 y's on the bottom. Well, if I have 6 y's on the bottom and an entire 7, that means I can cross out 6 of them, which leaves me with only 1 y on the top. And that's my final answer. Can't do anything else. So what I suggest is that you sort of distribute the fact that you're going to have some negatives. Once you deal with the fact that you might have some negatives here, negative exponents, and you flip all the negative exponents, if your negative exponents on the bottom, move it to the top. If you have negative exponents on the top, move it to the bottom. Then start canceling out. This is sort of a nice organized path. If you want to do something else, you're more than welcome to, but it's kind of a nice organized path, so that's why I'm doing it this way. I am actually going to now treat you to